So I write a lot of Angular and AngularJS code, but the truth is I don't actually have a lot of experience with modules because for the most part I just jam everything into the application module. It's a grab bag of globally unique dependency injection tokens and life just goes on. But this year I wanted to try and focus a little bit more on packaging cohesive sets of functionality, specifically around design systems. So I thought I would start to think more deeply about how modules can be used to organize code. And as a fun exploration, I thought I would try to create a password strength module, a module that would allow me to take a password input and as I type into it, provide some sort of visual indicator as to the strength of that password. You can see it starts out as very weak, and then as I type, it becomes weak, and then good, and then strong, and then eventually excellent. Now, out of the box, I want my password strength module to provide a default calculation, but I also wanted to wire it all together in a way that would allow the parent application to provide its own calculation if it wanted to. And to see this, we can use the silly calculator. And you'll see here that I have silly in the URL. And what that's going to do is in my app module, it's actually going to provide an override to my underlying password strength service. And now when I type, you can see it's very weak and I have to keep typing a lot, and then eventually it jumps to excellent. So essentially the default calculator has a 5-tier rating, whereas the silly calculator has a 2-tier rating, which goes directly from very weak to excellent. And under the hood, it's using all of the same template glue and the password strength visualization provided by the password strength module. It's just providing a override to the way the calculation is actually being performed. So part of this is looking at how modules can be used to package cohesive sets of functionality, but also expose that functionality in a way that is extendable by the parent application. So let's take a look at how this is working under the hood. And what we want to do first is look at our password strength service. This is the service that the password strength module exposes that actually performs the calculation, translating the password input into some sort of a strength value. And in this case, the strength is just going to be a number, and internally I'm going to use this strength enum or enumeration to map human-friendly phrases onto numbers. And you can see here that as the numbers increase, the strength of the password increases as well. Very weak, weak, good, strong, excellent. Now, we want to expose a default implementation of our strength calculation, but we also want to allow the parent application to override that logic as well. So what we're going to do is actually expose a abstract class password strength service, and this abstract class is going to act both as an interface that tells the parent application what it would need to provide if it was going to provide an override, but it's also going to act as the dependency injection token for our service. Now, we can't actually use an abstract class to define the underlying logic, so what we're going to do is provide a default implementation, default password strength service implementation, which actually extends the abstract class here. So again, we're going to be using the abstract class both as a interface and as a dependency injection token, and we're going to use the use class portion of the injectable metadata to define our default implementation. And the default implementation for our password strength service just uses a fairly straightforward length-based approach. If it's less than or equal to 5 characters, it's very weak. Then for 10 characters, it's weak. For 15 characters, it's good. For 20 characters, it's strong. And anything above 20 characters is excellent. I am not a security expert. This was just for the sake of the demo. Please do not take this to mean that this is how password strengths are actually calculated. Okay, so now that we have our password strength service, what we can look at is how this can be overridden in our application module. So if I jump into our application module, what we'll see is that I'm importing the password strength service from my password strength module, and we'll look at that module in a little bit. Now remember, this is the abstract class. So not only is the abstract class acting as our interface, which we're going to use when defining our own override, it's also going to act as the dependency injection token, which we'll see in a little bit. So in the silly password strength service, which is our override of the calculation, you can see that we're implementing that abstract class, which means that we have to provide the evaluate password method, which takes the password and returns a number. And in this case, we're also using the length of the input, but the calculation here is much more silly. Anything less than 20 characters is considered very weak. Anything 20 characters or over is considered excellent. Now, when we go to define our application module, I'm going to look at the location, the URL of the browser, to see whether or not I should be defining the override. So if the location starts with silly, then what I'm going to do is take that abstract class, password strength service, and say whenever a class within the application asks for the password strength service type, what we're actually going to do is provide the silly password strength service override. So what this allows the Angular application to do is use this dependency injection token everywhere, and then having a sense of encapsulation of what that actually means, we can now override that within our application module, and the rest of the application doesn't have to know anything about it. And then of course we're going to import our password strength module, and that is how we get the difference here between the default multi-tiered password strength calculation and the silly calculator, which only has very weak and excellent. But again, as I said before, we're using the same underlying template glue, including this visualization component, which is being provided by the password strength module. So let's dig into that to see how some of this glue works. So first, I guess let's look at the application component HTML. So this is our application component. You can see here's where we're switching between the two calculators based on the URL. And here is my password input. And my password input includes this attribute directive provided by the password strength module, password strength. And what that's going to do is actually expose an event, which I'm not using in this case, but it would have been strength, and this would have exposed the calculation of the translation of the password value into the strength. But in this case, I'm not actually using the event. What I'm using is the instance password strength, which is exposed as password strength, and I'm assigning that to a template local variable called password. Now I'm then using that password instance reference to grab the calculated strength, and I'm going to pipe that into the input binding of this password strength indicator, and that's the visualization here down at the bottom. Now this password strength indicator is being provided by the password strength module, which let's jump back into our application module. When I take this password strength module and then I import it into my application module, I now get access to all of the directives that are being published by the password strength module, of which both the password strength directive and the password strength indicator component are included. Now it's also here using the password ref, and in this case that just grabs a reference, a template local reference to the DOM element itself, which gives us the ability to then reference the value on that input DOM element, which means that we're just going to hide the indicator here if there is no value. So we're only going to expose a password strength if the value has been entered. And again, that's just to keep this a little bit more interesting. So let's now take a look at password strength attribute directive to see how that works. And here we go. So you can see that it is binding to input when it has the attribute password strength. It's going to expose a strength output, which is just an event emitter. And what it's going to do is bind to the input event on the host element. So because we're on the input, this password strength attribute directive is going to be listening to the input event on this host element, and it's going to be using that to calculate strength. So if we go back to our directive here, it's going to take that input event, it's going to pipe it into this evaluate input value passing in the value of the input, and then you can see that the evaluate input value takes that password, passes it to the evaluate password, which is the method on our password strength service, calculates that as a strength. It's going to emit that strength on the output binding, but you'll notice that it also stores it as a public value on our strength event directive. Now this public value that's being calculated, that's how, if we jump back to our app component, that's how when we get a reference to the password strength instance, we can then reference that strength property on that instance, piping that as the input binding to our password strength indicator component. Now, if we jump back again to our event directive here, what you'll notice is that it's injecting, as part of its dependency injection in the constructor here, the password strength service abstract class. Now, because that is an abstract class, it may be the default implementation provided by the password strength module, or it may be the silly password strength calculator provided by the parent application. This is the beautiful, beautiful part of dependency injection in Angular, is that this event directive doesn't have to know which version of the password strength calculation is being provided. It just asks for a type, and Angular at runtime will provide the type defined by the way the modules have been glued together. Just part of what makes Angular so elegant, in my opinion. Okay, so now we've looked at the event directive. Now let's go ahead and look at the password strength indicator component, which shows us the visualization of the password. Now, the indicator doesn't do very much in and of itself. We can see that it just exposes that input so that we can take that strength and turn it into a visualization. And the HTML under the hood essentially just looks at that strength, and you can see as an NG switch. Not a whole lot going on here. Now, let's take a look at how all of this is actually packaged together and exposed as the password strength module. So if we look at the module, what we can see is that it exports its directives, the event directive, which allows us to bind on the input of type password, and the component here, which allows us to use that visualization based on the strength. Now, what you'll also notice is that it is explicitly exporting services and components. Now, technically, I don't really need to export the directives of the components here. I don't actually reference them in any way in the parent application, but they could be useful if I need to reference them as a type, perhaps in some sort of a view query, view child query, or content query. But I am exposing the password strength service and the strength enumerator. And the reason that I'm doing that is that so when the parent application needs to reference these things, it can reference them from the module itself without having to actually know the underlying file system. So essentially, the exports here create a public API for the services which hide away the underlying file organization, which means that if we jump back into our app module, for example, and we go back up to the top, you can see that the password strength service here isn't actually being imported from the password strength service file. It's being imported from the password strength module. So it doesn't have to know how the password strength module is organizing the files under the hood. It's simply importing everything directly from the module, which allows a degree of indirection between the underlying file structure and the consumption within the parent application, and that encapsulation allows the file structure to change independently of the rest of the application. So that's really all there is. I'm relatively new to thinking about modules. As I said before, mostly I just take everything and jam it in the application module or a lazy loaded feature module for routes. I don't typically, or I don't historically think about packaging cohesive sets of functionality, but I do want to make that something I think more deeply about this year, and this just seemed like a fun exploration in that context. So hopefully something interesting here, and hopefully I didn't say anything too terribly incorrect.